Hello, this is Mike Panaki with Network Protocol Specialists, and in this video we're going to take a look at a way that we can determine if TCP window size is what's holding back your data throughput. And so what we're going to do is we've got a trace file right here, and this is a trace file I created by using the iPerf throughput tool. And I did it over an emulated WAN link where there was 0 packet loss. So the first thing we're going to do is we are going to go in, we're going to take a look at this conversation. And at the very beginning of this conversation, we see the TCP three-way handshake. We see a SYN acknowledgement, and then an acknowledgement. Now in this case, 10.0.0.111 is the device that is going to be sending the data, and 128 is going to be the device receiving the data. So what I'm interested in is the TCP window size of the receiving device. So here, I'm going to bring this up, and I'm going to select on that SYN acknowledgement. We're going to look at the TCP header, and we're going to look at the options. So we're going to expand that. Now the options give us some information about the receiving device. First off, our maximum segment size says that we shall not ever send more than 1,460 bytes at one time to that device in any TCP segment. Also, we see a window scale factor of 0, which says multiply times 1. Now this is important because if our scale factor was greater than 0, we would raise 2 to the power of the scale factor and multiply it times our window size right here. In this case, because our scale factor is 0, we take whatever window size is advertised, and that's what we use. So this tells us that the receiving device cannot handle more than 65,535 bytes at one time in flight. So now that we know that, we're going to come in here, we're going to slide that down, we're going to add a new column to our window. Now the way I do that is I come up and I click on Edit, Preferences, and I come in here and I go to Columns. I'm going to say Add. Now it's going to put a new column down here at the bottom. Now what I'll do is I'm going to select that and I'm going to scroll all the way up until it says Custom. I'm going to click on Custom. And down here in Field Name, I'm going to type in the field I'm interested in. That'll be tcp.analysis.bytes in flight. And so there are a number, there's all kinds of fields that we can create as columns. This is one that we can go in and it will calculate how many unacknowledged bytes are hanging out there at one time. And I'm going to give this a name that makes sense. We'll call it bytes in flight. And then I'm going to drag that up here. I'm going to drag that up to right after the time column. This is something I've found when I'm recording. Sometimes I can't always drag it. So we'll say OK. We'll go ahead and add this. And what we'll do is it's going to put bytes in flight in there. We are just going to drag it over in the GUI. Sometimes with the Camtasia software here, it does not want to move. So now, what this does is this adds a new column to our Wireshark screen, and it shows us how many unacknowledged bytes are hanging out there in the ether. And the idea is our unacknowledged bytes should never exceed the TCP window size. So if I start scrolling down, we can actually see slow start in action here, and we'll see that the total number of unacknowledged bytes keeps going up. So there we were at 13,140, and we received acknowledgments. Then we went up to 18,980, we received acknowledgments. Then we went up to 27,740, then 33,000, then 43,000. And what we'll see is that we will edge ever closer to our 65,535. So right here, we're at 65,532. So we're very close. We're within 3 bytes of that TCP window size, and that's where we want to be. So this tells us that we have used up and we've filled up that pipe. And what we see is that our acknowledgments, if we look at our time value over here, which in this case is time between previous packet, that there isn't a lot of time between when we hit that 65212 and when we get the acknowledgments back. So that's great. That means that we are taking full advantage of that pipe that is out there. So we're getting good throughput in here. So this is an example of where our application's working well and we're taking full advantage of the TCP window size that's being advertised. If we came up and I said File, let's open a recent one, and I'm going to say I want to open this one. Now this one is one where I've got some packet loss. And so in this case, we start coming up, and what we find is as we scroll down, we never come close to that 65,535. And that's because we are seeing packet loss and we've got retransmissions that are occurring. And that packet loss is causing us to have to back off and continually go back into slow start. And in fact, if we took this and we clicked on any one of these frames where we've sent data, and we come up and we look at statistics, and we go to TCP stream graph, and we look at the Stevens graph, we can see in this case, this is not a very good looking graph. We're seeing that this is showing us that we're having to back off. And in fact, if we come in and we hold down the shift key and I hit plus, I can zoom into the graph. And what this is showing is that this segment was transmitted here and then retransmitted here. And that results in, that says that we're seeing packet loss, and that means that we're having to back off. So by using the Stevens graph, now I'm going to hit the minus key and I'm going to zoom out. By using the Stevens graph and graphing out that data flow, we can see, are we seeing a nice straight line? In fact, let's go back. We're going to close that. We're going to come back here. We're going to open this again, and we're going to do that same Stevens graph. We're going to grab a frame that has some data, not an acknowledgement. We're going to go to statistics, and we're going to look at the stream graph. We're going to look at Stevens, and this is what that good transfer looks like with no packet loss. So this is how we can use a new column, the TCP Bytes in Flight, or TCP.analysis.bytes in flight, and see, are we taking full advantage of our TCP window? Then we can use the Stevens graph to graph out that transfer, and you don't have to be a rocket scientist to be able to look at the difference between these two graphs and see an example of a graph where we have good throughput and we have a nice straight line, and a graph where we have poor throughput and we have packet loss and the graph doesn't look so good. So I hope this helps you out when it comes to diagnosing problems. And with using the bytes in flight, if we see that there's a big gap between the time that we reach our maximum window size and when we receive that first acknowledgement, this can be an indicator that our TCP window is not big enough. So happy troubleshooting, and keep looking at those packets. That's the best way to get better at it.